Hello everyone and welcome to the class of Emerging Trends in Microeconomics Research, Econ 413, lecture number 16, and today we are going to discuss about utility. So starting with the utility function and defining what utility is, I would refer back to our previous discussion that was on the properties of consumer preference. And the properties, there were 5 properties that we discussed that were the completeness, the transitivity, and non-satiability, continuity, and strict convexity. And based on those properties, we basically derive our indifference curve. And the indifference curve tells us about a curve on which the utility is constant. But we didn't discuss what utility is. So we need to understand utility. Utility basically, in order to compare various bundles of goods and decide which bundle gives an individual or consumer more satisfaction. So we can summarize a consumer preference by assigning numerical value to each possible bundle to reflect the consumer's relative ranking of those bundles. So, following the terminology of the 19th century economist, an economist applies the term utility to a set of numerical values that reflect the relative ranking of various bundles of goods. So, it is basically related to the ranking of bundles and ranking of bundles in the sense that it gives an individual certain level of satisfaction. All right, so let's say that we have a bundle X and X has 2 goods, and then we have another bundle Y, and Y has again 2 goods but in different quantity, and we need to compare these 2 bundles so we can rank them. And let's say that X, the bundle X, that gives individual 10 utils, and bundle Y gives an individual 20 utils. So which of the two gives more utility to the individual? Obviously, bundle Y has more utility as compared to the bundle X. So basically, utility is meant to rank the satisfaction of individual that is achieved from consuming various bundles, and those bundles consist of combinations of various goods. A utility function, on the other hand, is a relationship between utility measures every possible bundle of goods. So we have various possible bundles. We have 2 goods in them. One we call Q1 and the other we call Q2. These 2 goods are being consumed, and we have a large set of bundles X, Y, Z, and so on. We have a large set of bundles. A utility function will cover all these bundles by changing either of Q1 or Q2. So we will see whether if increasing Q1 by 1 unit, that will give us another bundle, and we will see how utility changes with each and every extra unit that we are putting into this bundle. So utility is basically a function of let's say in this case Q1 and Q2, whereas Q1 and Q2 combination will give us the entire possible uh, bundles that we can make with these two quantities. So let's say that we have a consumer, and the consumer has basically a bundle X, and in that bundle it consists of 16 pizzas, as well as it consists of 9 burritos, right? And we should see whether this gives her more utility as compared to another bundle Y, which consists of 13 pizzas and 13 burritos. So which of the two will give her more satisfaction or more utility? So the utility that she gets from y is, if let's say we are using a utility function such that u is equal to q1 and q2. So we will need to calculate the utility for both of these bundles. Utility of bundle x will equal 16 into 9 under root, and the utility of bundle y is equal to 13 into 13 under root. So basically this gives us 13, as 13 square cancels out the the root. Then we have 16 into 9, and then taking the under root of it we get 12. So obviously from this example we can see that utility of y is greater than utility of x. So we can rank these bundles based on the utility function that we are getting. The utility function is a concept that economists use to help them think about consumer behavior. Utility functions are not real, they do not exist in the fundamental sense. And that's true because if you ask someone how much utility you get from consumption of certain commodities, he cannot tell you exactly whether he gets 13 utils from that, whether he get 20 utils, whether he get 1000 utils from it. So one does not identify utility in the number sense. Let me ask you the same question. If I ask you how much utility you get from a glass of water, so you cannot tell me whether you are getting 10 utils or 15 utils from a glass of water. But of course, for the comparison purpose, if I ask you that, let's say if you have to assign marks to something, a glass of water with a cup of tea, so how much marks can you give a glass of water and how much to a cup of tea? And if you tell me that I give a cup of tea 15 marks and a glass of water 10 marks, then it gives me the message that you prefer a cup of tea more to a glass of water. And similarly, the reverse is true. If you are assigning 15 utils to the water and 12 utils to a cup of tea, then obviously you prefer water more to tea. So a typical consumer can easily answer questions about whether they prefer one bundle to another, and but they cannot give you the exact answer that how much utility they get from the consumption of certain commodity. So this utility function, the next thing that we want to discuss about is that whether this utility function is cardinal or ordinal. If we know only consumers' relative ranking of bundles, a measure of pleasure that is is ordinal rather than cardinal. Ordinal basically the word means that something that can be presented in ordered form, or that can be presented in rank form. And ranking means we prefer x first, then y, then z, and then so on. So we can make a list out of it and say that we prefer which one first and which one the second, which one third, which one the fourth, so and so on. Whereas cardinal basically actually gives the values to it. For example, if you want to find the weight of each and every individual, and you can weight that individual based on certain using certain scale, and you can get the results as 60 kg, 70 kg, 76 kg. Now this is cardinal. The numbers actually mean something. Whereas when we talk about the utility and we assign utility of 10 to y and utility of 12 to z, these 10 and 12 and all these numbers that we assign to utility does not mean anything. They are only for the purpose of ranking, and there is no other purpose other than ranking. So we say that utility is basically an ordinal measure. It is just for the purpose of ranking. And why is this important? This is very much important because let me give you an example and you will understand why we say this is ordinal. Let's say you meet a person and you ask him a question: how much utility you get from consumption of chicken roast. So he tells you that the person X tells you that he gets 20 utility from the consumption of a chicken piece. Then you meet another person, another friend of yours, and his name is Y, and you ask him the same question. You ask him whether how much utility he gets from the consumption of a chicken piece, and he tells you that his utility from the consumption of chicken piece is 30. Now, can you know who likes chicken more? Whether whether the individual X get more utility from the consumption of chicken, or whether the individual Y gets more utility from the consumption of chicken. So mathematically, obviously, you see that Y gets 30 utilities and X gets 20. So Y must have more satisfaction from X. But this is not true. Why? Because we don't know how individual X assigned the value 20 and how individual Y assigned the value 30 on which category and how he did that. So this assigning of this is basically ranking. So these values that they have assigned, they are not interrelated and they are not intercomparable. They are just for the ranking purpose, and possibly individual X gets a better satisfaction than individual Y. You know that we cannot compare the satisfaction one gets from certain goods. If two persons are in front of you, you cannot decide who gets more satisfaction, even if they tell you that cannot entirely be true. So an ordinal scale is comparable for that individual. If the individual X tells you that he gets 10 utility from consumption of bread and 20 utility from consumption of chicken, obviously now you can rank it and you can say that he gets more utility from consumption of chicken rather than bread, but you cannot cross compare that with other individual. Similarly, individual Y may also compare his utility with bread and he gets 50 utilities from bread, 30 from chicken. So he gets more utility from bread than chicken. But again, the same is true. His comparison with X is not possible. So we know that these numbers, the numbers 20 and 10, they are not unique and they can be positively they can have a monotonic transformation, and positive monotonic transformation means that if let's say individual X is consuming three commodities A, B and C, and from A he states that he is getting 20 utilities, from B he is getting 30 utilities, and from C is getting 40 utilities. This statement is equivalent when he states, or when we transform it by multiplying certain amount with it or by adding certain amount with it. Let's say instead of 20 we write it as 40, 60, and 80. So these utilities are identical. They can monotonically be transformed, positive monotonicity. So again, the order is not changing. When we do that, the order is not changing. We still have the same order. We cannot do any negative monotonic transformation. That means that instead of 20 we multiply that by a -1, and that will give us -20, -30, and -40, which basically changes the sequence, changes the order, changes the ranking. So negative transformation is not possible, but the positive monotonic transformation is possible in case of the utility functions. Let us now understand the relationship between utility and indifference curve. What is utility and what is indifference curve? We understand that a utility function is equal to, let's say it is a function of q1 and q2. Now, keeping one of them constant, when we increase the second one, if let's say q1 remains the same, we were consuming 16 pizzas and 9 burritos. But now when we are consuming 16 pizzas and 10 burritos, utility will increase. Why? Because of the principle of non-satiability. When an individual or a consumer always prefer more to less. So the second bundle that now consists of 10 burritos, whereas the previous bundle consisted of 9 burritos. More is always preferred to less. This gives us a higher utility. But if instead the new utility function comprises of lesser pizzas, let's say 14 pizzas, but we increase the number of burritos, let's say that is 10, or let's say that is 11. So number of burritos has increased, whereas number of pizzas that has decreased. Now there is a possibility that this new combination, this new bundle gives us the same satisfaction. We had the initial bundle U1 and the second bundle U2. So the second bundle has the same utility. Similarly, we can have a third bundle which gives us let's say 12 pizzas and 14 burritos, and then that may also give us the same utility. When utility remains the same and we are changing the goods in the bundle, we are increasing one good and decreasing the second good. In this type of situation, when we graph them, when we combine all these bundles, this graph or this curve is known as the indifference curve, which comprises of various combinations. Let's say if y-axis is for pizza and x-axis is for burritos, we had 16 pizzas, 9 burritos, then we had 14 pizzas, 11 burritos, then we had 12 pizzas and 14 burritos, and all of them are giving us the same utility. And all of them are giving us the same utility, and all of them lie on a single curve. That curve is known as the indifference curve. And we should also know that higher indifference curve gives us more commodities than the lower indifference curve. Therefore, the utility of higher indifference curve is more. Lower the indifference curve, lower the utility. Higher the indifference curve, higher the utility. And there are certain other properties of the indifference curve, that two indifference curves cannot cross each other, indifference curve cannot be thick, and a number of other properties, but we are not going to discuss that here. Then we also have the concept of marginal. Okay, but before discussing the concept of marginal utility, let me use some mathematics for this indifference curve. That is, we have a utility function u, which is a function of q1 and q2, and for this to be an indifference curve, the utility will remain constant. The dash above u means that a utility will not change, whereas the quantities within this function can change. So this expression determines all those bundles of q1 and q2 that gives an individual a constant utility. And we have seen that how we can change the quantities within this function. When we increase q2, we'll have to decrease q1 in order to maintain the utility, in order to keep this utility constant. And we'll also see that how we name this change, so we'll discuss that as well. Let us also discuss the marginal utility now. To understand this, we analyze how consumers make choices when faced with the limited resources, and it is useful to know the slope of an indifference curve at a particular bundle of goods, and economists call the slope of indifference curve as the marginal rate of substitution. So let me write that: the marginal rate of substitution, and in short we call that MRS. So we understand the indifference curve, that is, we have two goods q1 q2, and the various bundles of q1 q2 gives us indifference curve. Now when we want the utility to remain constant, as we have discussed now, q1 and q2, if we have to increase q2 and keeping the utility constant, we will have to decrease q1. At what rate do we how much have to of q1 have we to sacrifice in order to keep the utility constant? That is basically called the MRS, and that is represented by the slope of the indifference curve. So here the slope is you may say that it is an equivalent change is required for q1 and q2, but at certain other stages, for example over here, we have to sacrifice less of q1 and more of q1 and less of q2 in order to keep the utility constant. So this slope is basically called the marginal rate of substitution. Now, because it is the maximum amount of one good that a consumer will sacrifice and trade in order to obtain another good, an individual willing to trade one good for more of another good, it will cause the downward slope of this indifference curve. We can use calculus as well to determine the slope, and we can use calculus to determine the marginal rate of substitution, and we will show this MRS depends on how much extra utility an individual gets from consumption of an extra unit of good, and we call this as marginal utility. So marginal utility is basically an extra utility obtained from consumption of one more unit. We have Q1, we have Q2. If an individual consumes one more unit of, let's say he was consuming 10 pesos and now he's consuming 11 pesos. How much additional utility has this extra unit given? That utility is called marginal utility, and this marginal utility is important for the derivation of MRS. So marginal utility basically declines as we consume more and more of a certain good. Let's say we have Q1 and this is utility and we are consuming 0 units. When we are consuming 0 units, we have 0 utilities. The first unit give us more utility. Second units give us more utility but lesser than the first unit, and so on until the utility curve is slope gets 0. So here we have a 0 slope, and initially we have a higher slope, and if you consume more, the slope might get negative. This is basically when you observe that when an individual is thirsty and he wants to drink water, one glass of water gives him a good utility, but the second glass of water does not give him extra as much as utility as the first glass. Obviously, the second glass has its own utility, but that is lesser than the first glass. So marginal utility is basically the change in utility due to a change in the quantity of pesos consumed, or as we have described earlier, utility is function of Q1, Q2. So marginal utility will be equal to the derivative of Q1, Q2 to the derivative of Q1 to the change in Q1. And similarly, if you want to find the marginal utility of the second good, then we will have to differentiate this equation with respect to Q2. Now when we keep the utility constant and when we consume more of one good, then we consume less of the other good. So the marginal utility of one good will increase, the marginal utility of other good will decrease. And this is basically if this marginal rate of substitution is basically equal to the marginal utility of one good divided by the marginal utility of other good, and its slope is negative, therefore we put a negative sign along with it. How we determine this marginal rate of substitution mathematically? We know that when we want to change a typical utility function that we are using is function of Q1 and Q2, and when we increase Q1, the marginal utility that is mu1 will increase with a diminishing rate. Similarly, when we increase Q2, mu2 will increase with a diminishing rate. But an indifference curve, when we talk about indifference curve, utility is constant. So when we increase Q1, we will have to decrease Q2. So now Q2 is not independent, rather than Q2 becomes a function of Q1, because when we change Q1, in order to keep utility constant, we will have to change Q2 as well. So our new utility function can now be rewritten as Q1 and Q2, which is a function of Q1. Remember, this is not multiplied but simply a functional representation that Q2 is now a function of Q1. So if we want to find a change in this utility function because of a change in Q1, change in the indifference curve, change in the utility function, and we know that is constant. When we change Q1, how can we measure this? What will this be equal to? This will be equal to 0. Why? Because when we change Q1, we will have to decrease Q2 in order to keep the utility constant. So utility on indifference curve does not changes. So total utility function of Q1 and Q2 with respect, which is also function of Q1. When we want to find the derivative with respect to Q1, this is first we take the entire utility function with respect to Q1, but again we know that Q2 is not constant, so we will have to use the chain rule in order to find the change in Q2 due to change in 1, that is Q2, which is function of Q1 due to change in Q2, and as we are using the chain rule, then partial Q2 to partial Q1. So the first equation, this is we are basically finding derivative of utility to Q1, which is equivalent to 0 because utility will not change on an indifference curve. First we take derivative with respect to Q1 and then we take derivative with respect to Q2, but we are actually finding the change in utility due to change in Q1. So when we do that, we also have to find the change in Q2 due to change in Q1. So basically this effect cancels out each other and we are basically finding the change in utility due to change in Q1, more specifically about the change occurring due to Q2 in Q1, and then summing up we get the total change, and that is equal to 0. Then we know that let me write that in shorter version instead of writing Q1 and Q2 with all these equations again, plus change in utility due to change in Q2 into change in Q2 due to change in Q1. This entire is equal to 0, and we can rewrite this equation: change in U due to change in Q1 is equal to minus change in U due to change in Q2 into change in Q2 due to change in Q1. So change in utility due to change in Q1 is basically marginal utility because of the first good, and it is equal to marginal utility of the second good into change in Q2 due to change in Q1. And again rewriting that, change in Q2 due to change in Q1 equals, shifting this thing, marginal utility of 1 divided by marginal utility of 2, and the negative sign remains in its place. So this is how much we can change Q2 for Q1 on an indifference curve. In order for utility to remain constant and we have Q1 here, we have Q2 here. When we want to increase Q1, how much of Q2 we will sacrifice basically depends on the marginal utilities of both the quantities. So I hope you have understood this, and if you have any problem, please do ask in the comment section. Thank you very much.